All right, so here we go. Number 5, we're going to go to 5 and 6. Tara is a pilot, and it's going to drop a bomb on an enemy storage depot. So that means there's nobody there. With a camera mounted under the plane, she watches the bomb drop. Annie is an observer on the ground who also watches the bomb drop. So, Tara is the pilot. Annie is the observer. She's on the ground. Assume the air resistance is small, so we'll just say negligible. We're going to draw a trajectory. So we know from question 4 what trajectory is, so I'm not going to explain that. But we're going to draw it from the frame of reference of each person. So the first question is the frame of reference of Tara, and B is the frame of reference from Annie. So Tara's in the plane, right? So keep in mind, this is my plane. Alright, so there's my plane, right? When they drop a bomb, they're going a certain speed. When the bomb comes out, it's going a certain speed. So from their frame of reference, it pretty much goes straight down. Right? So if we just wanted to draw the deal, the bomb, it's going to go straight down. Now why does it go straight down? Because let's say the plane's going 300 meters per second. Well, the bomb is going 300 meters per second too. So it's going 300 meters per second. Therefore, they're going the same speed when it drops, right? So the only thing that's going to be different about the plane and the bomb is the bomb's going to go down because the bomb has nothing like keeping it in the air. Therefore, it's affected by gravity, so it's going to go down. So from the plane's perspective, since they're both moving right at the same speed, it just goes straight down. Done, right? So now we're going to look at Annie's frame of reference. So remember, Annie is standing on the ground, not moving. So Annie, 0 meters per second, not moving. So from her reference, she's not going 300 meters per second. She's going 0. So from her point perspective, this bomb gets dropped. Let's say here. It's going to take some time to hit the ground. So really it's going to be something like boom. Right? So from her perspective, it's going to kind of follow this line here. So hopefully that makes sense. Just like if you're running and let's say you have a bouncy ball and you're running, or a tennis ball, and you're running at 5 miles per hour and you drop the tennis ball. From your perspective, it drops straight to the ground because it drops beside you. You and the tennis ball are both going 5 miles per hour, right? If somebody's sitting on the ground and you run past them and drop it, it's going to travel some distance forward before it hits the ground, right? Because they're not moving that 5 miles per hour. So that's why it looks that way, right? So with that being said, keep in mind all this stuff we covered when you do number 6. Remembering that everything on the vessel that's traveling at a speed is going that speed. So if you're in an airplane going 300 miles per hour, you are also going 300 miles per hour, right? So keep that in mind when you do number 6 when it's saying a sailor's in a crow's nest. That's like the place up high that they like look with their telescope. They look for land, right? And they're sailing a ship moving at a constant speed. I'll just start this one. So that means the ship is at a constant speed and they are also going that same speed, right? And there's a tool deck below. Would the tool land directly beneath where he dropped it since the ship is moving, would it land further back? In other words, he's on this ship, right? And he's got this wrench. Not drawn to scale, right? If he drops it, will it land directly below him? Or, since the ship's moving, will it land back here? So that's the question. Keep all this other stuff in mind, and there you go.